Today we'll be learning about the law of sines, which can only be used given an acute triangle, which is a triangle that has all angles less than 90 degrees, or an obtuse triangle, which has an angle that is greater than 90 degrees. The formula you're given is A over sine A is equivalent to B over sine B, which is also equivalent to C over sine C. This can be reciprocated into sine A over A equals sine B over B and sine C over C. You can only use the law of sines if you're given two angles and only one side, so it would be angle, angle, side, or angle, side, angle, or two sides and an angle opposite of them, which would be side, side, angle. An example of this would be to solve the triangle given. Here you're given an angle of 110 degrees, so you know it's going to be an obtuse triangle. You're given the side opposite of the angle, which is A equals 125, and you're also given another side, which is B equals 100. To start off solving any problem, I like to draw it out before starting. So an obtuse triangle is going to look something like this. Probably a little bit too exaggerated, but that's okay. This angle here is going to be the 110 degrees. This would be A, so it would be 125. And you can choose any other value for B, but I'm going to say B is right here. So this would be 100. And then this would be C and a little c here. To start off by solving this, you would most likely solve for B first. So to start off, you'd have, and you're trying to solve for the angle. So you're going to want the angle to be probably on the bottom, would be the easiest way to do it. So you'd have sine 110 degrees divided by 125 equals sine of B over 100. Now this is really easy to solve because all you do is multiply 100 on each side and this side, and you get sine B equals 100 sine 110 divided by 125. You aren't finished here though, because you need to get rid of the sine to figure out what the exact angle is. So you need to take the arcsine of both sides. So then the last value you'd get would be sine of, so the arcsine of 100 times the sine of 110 divided by 125 equals angle B. Now that you found angle B, you could write this in, but since I don't have a calculator with me, I'm just going to leave it how it is, so I won't write this in up here. Instead, I'm just going to solve for angle C, because I know that all these angles added together, A, B, and C, are going to equal 180 degrees. So I know that angle A is 110. I know that angle B is this weird value right here, so plus the arcsine of 100 sine 110 divided by 125 plus C equals 180. So I'm going to minus this over, so I'm going to get C equals 70 minus the arcsine of 100 sine 110 divided by 125. Okay. So now that I know that this is the angle of C, I can go on to solve the side of C. To solve that, I'm kind of running out of room, so I'll go over here. you'd have you'd have 125 over sine 110 equals side C divided by the sine of, well, C, but that I don't feel like writing out. So you multiply times sine C. These will cancel out, times sine C. The C is this huge value right here. And you're going to get the little c equals 125 sine C divided by sine of 110. And that would be the final answer because you have side C here, you have the angle of C here, and you also have the side or the angle of B here. So you've completed the triangle, and you can put those back in if you want to write the triangle all out, but we don't need to here. For a little bit harder of a problem, here's a word problem. Because of prevailing winds, a tree grew so that it was leaning at a 4-degree angle from the vertical. At a point of 40 meters from the tree, the angle of elevation to the top of the tree is 30 degrees. Find the height h of the tree. So again, start out by drawing the tree. You're going to know that since the vertical would be 90 degrees, but since it's leaning 4 degrees from the vertical, you know that it's going to be an obtuse triangle. So you draw that out. Again, actually that's only needs to be 94, so it could be a little bit more straight up. So say like this. And this would be the tree right here. This point, since there's a point 40 meters from the tree, this would be 40. And this right here will be 30 degrees. And you want to find this side right here, which is opposite what we'll call angle A. And you're given side B here. And this angle, you already know, is 94 degrees. Since you know these two, you also can find B. So you add 94 plus 30 plus C, or plus B, my bad, equals 180. So B equals, let's see, it'd be 180 minus 124, so it'd be 56. So B would be 56 degrees. So I'll write that in here. 56 degrees. All right. Now that you have all of the angles, now you can move on to solve for this side. So we can do A over the sine of 30 degrees equals B, which would be the 40, over sine of B, which would be the sine of 56. So we know that the sine at 30 would be 1/2. So we'd be multiplying this side by 1/2 exactly. So A, I'll cross this out right 1/2, since we already know that value. So then you're multiplying each side by 1/2. Same thing as dividing by 2. So you have A, sine A equals 20 over the sine of 56. This would be the distance in meters of how tall the tree would be. And that concludes the examples on how to use the law of sines.